Thank you. Yes, so telemetry in the small, or metrics in the small. So we're going to be talking about how we can do telemetry for nerves-based devices. So I'm Matt Ludwigs. I work at a company called SmartRent, where we do IoT development for property management-based and multifamily-based. I also do a bit of nerves on the side where I contribute to some nerves projects, and I also developed a library called Grizzly that allows you to do home automation with a protocol called Z-Wave. You can find me on GitHub with my name, Matt Ludwigs, and then on the Elixir Lang Slack channel, there's mwigs is my handle, so you can always reach out to me there. Before we jump into the bulk of this talk and talking about IoT and all the fun stuff, I think it might be a good idea to get a good overview of what observability is. As I was learning about observability, I came across this post by Alexis Jones from New Relic, and the post was amazing at helping me understand. But really, observability allows us to understand our system, typically complex systems. I like to think of observability as that kind of next layer to the building robust, solid software products, because we have testing and we have types, even though there's lots of opinions around both of those, but both of them are supposed to be tools that help us build solid software. I think observability is at next level because those are typically sandbox, kind of well-known environments. Things operate in a particular way, and even though we try really hard to account for a lot of things that might come up in a real-life production system, it's sometimes hard to capture all that in just tests. So observability allows us to just dig into the living, breathing system and see what's going on, and hopefully make our software better and help us prioritize work. So I really have learned a lot and really like observability. In New Relic also posted a white paper called Melt 101. These are the ingredients that go into building an observable platform. These are metrics, events, logs, and traces. With metrics, they're typically your aggregates that are often collected at a sampling rate. Not always. You can have them come in as they come in, but oftentimes you're saying, hey, check the CPU usage of this. Tell me my memory every second. And so you can start looking at what's your average memory usage, what's your CPU usage over time. These really give you that high level view of what's going on, and they're not terribly granular. For example, you're not going to necessarily drill down to what might have caused CPU usage to go up. Those will be some of the other items that can help you look into that more. But these can give you that really good, solid, high-level overview of what's going on in your system and what's going on in the system over time. It's really nice. Elixir provides the telemetry metrics package. This is a very standard way to define metrics and to integrate into doing metrics with Elixir telemetry. The next thing we have is events. These are more discrete and they happen in a moment of time. They're usually an action has to happen. So a user presses a button or the system starts some type of process, right? These are events. They're very granular. They're very, this happened now, this happened at this time, this happened at this time. And they're a really, really good way of digging into your data about your platform, and asking questions and solving a bit more granular analyst. Oftentimes these can get confused. At least when I was learning about it, I was like, these seem very similar. And I think you can get metrics from events, and you could possibly drill down into your metrics to see kind of what event caused your metric to do something. But really it's the use case. Why are we using these things is what really kind of is the purpose. Metrics tend to be really well known. We want to measure, for example, our average request time, or we want to know how many times did did our hub reboot, if we're talking about nerves. These are things that we really know well beforehand, and we can specify that into our software. Whereas events tend to be a bit more, like I said, granular. So there's a lot more of them. You have to tend to pull those into some other platform to really start kind of doing some like exploratory data analysis or asking bigger questions about those the data that's coming out of that. And then logs and traces, they're not a big part of this talk, but I did want to give them like a honorable mention because I love logs. Anytime one of our devices has issues, I'm right to the console dumping logs, trying to figure out what's going on. And then traces are really nice because you can see the chain of events that happen from a single call. You can find bottlenecks in particular calls. You can see what happens across all the components in your software system, or even what happens between various software systems. So traces really are actually cool to like see how all that comes together. But all of these are really necessary for the observability story for a company. But this talks about observability telemetry for IoT. And imagine that you're starting a nerves project and you want to start collecting metrics on your system, what it's doing, how the network's going, things like that. And your first step you're tasked with is like, hey, we need to get metrics. So you go, okay, what are the existing platforms? So you look at the existing platforms, and there's a lot of existing platforms, way more than any of this. And some of these specialize in particular areas of observability or visualization, or maybe they're really special for like time series database for events. But there's a lot of things out there to help you do this, and there's a lot of decisions that need to be made. And then you have your nerves device, and you're like, okay, well, I can use one of these existing platforms, but maybe a better question is like, why wouldn't I? Like, why not? Why not use these existing platforms? Well, with an IoT device, there's many reasons why. They tend to assume a network connectivity. Basically, when you build an IoT device, even one that's supposed to be connected a lot, you have to assume that the network that your device is going to be put in is going to be fundamentally hostile to you. I think most of the pain I've experienced over the last few years building nerves devices has been with networking and all the various things that networking holds within it. I've taken for granted when I just open my laptop and I'm connected to a network. I know now that it's not that simple under the hood. So we can't assume that there's network connectivity. Oftentimes these IoT devices are built to automate. So a lot of stuff's happening at the device level, and they don't necessarily need network connectivity to keep running and keep doing stuff, which then generates events, which then you can get metrics, and you don't want to miss out on those metrics. So we have to assume we can't push up to a server. Oftentimes with LTE connections, if you're just constantly pushing JSON data up to a server, those bytes cost money, and that cost can be felt pretty hard. So it's not always best to just default for an IoT device of pushing JSON to some API endpoint. You can't really scale a device. If you're taking in all these events and trying to do all these events at the device level, and you start hitting some issues with memory or whatnot, usually these devices are out in the field, and maybe they're like locked away behind like a couple doors that you don't necessarily have access to. And so you can't just like walk over and scale it or hit a button in AWS and get scale. So there's some challenges of when you're processing all this information and trying to balance how you're using the network and how you're writing to disk and all these other things. You can't scale. So we have to take our limitations into consideration. And like I said, when you're writing a bunch, flash memory doesn't really, it can wear out. And so we have to be cognizant of that. And then oftentimes with these other solutions, they have SDKs, but they're built for other languages and platforms, and you kind of have to like shove that solution into your solution. And then just the cost of having another platform to integrate with. So what do? Do you shoehorn some existing solution and shove that in and say, this is good? Or do you build your own solution. And since we're software developers and given the option to build our own solution, I think we want to build a solution. And there are certain goals we want to have in mind as we build our solution. It needs to be local first. So that means we prioritize and optimize for not having a network connection. So our solution just assumes you can use it without a network connection, and it should still continue working, no problem. We want to integrate nicely with the larger Elixir ecosystem. So we want to be a good citizen within that ecosystem, be able to provide familiar APIs, and just play well with other libraries. We want to be useful with no central server. Oftentimes, you push data to your server, to whatever your platform might be. You log into that server. Then you can do analytics or data visualization. We want to be useful without that. So we want to provide an IEX-based way to see our data, see our metrics, kind of get some idea of what's going on, and also be able to grab the metrics that's there and pull that off the device. And then the last two are really specific to Nerve's device. We don't want to be writing to disk all the time, and we want to be memory considerate, which means we don't want to have unbounding memory where memory just keeps growing and growing and growing because we're saving all these events and all these metrics in memory because we're not writing that much to disk. So we don't want to just blow up the memory. So through these goals and a lot of development and thought, a solution was made, and that solution is called Mobius. I call it localized observability. And the reason why is because even though it was built in the context of nerves, you can actually use Mobius anywhere where you would use other telemetry packages. So the use case is beyond nerves, but nerves is the driving kind of force that dictates how some of the things operate within Mobius. So like I said, we want to integrate with the Elixir ecosystem well, and so we use telemetry and telemetry metrics. Mobius is a telemetry reporter, and if you don't know what that is when your telemetry event fires off. Mobius kind of sits here, ingests that, gets the metrics out of it, and sends that up to some backend. So the reporter is that middleware that takes your event, turns it into metrics, and then knows how to push that to whatever you're trying to store or aggregate or wherever you're putting that information. Mobius just does it locally. And like I said, with the Elixir ecosystem, it's a telemetry reporter, Mobius is, and this is how you configure what's the standard for the reporter configuration is that you give it a list of metrics, and then you pass that list to your reporter, and then that goes and is part of your supervision tree. It's one of your children within your supervision. So Mobius can be used like any other telemetry reporter. So how does it work locally? Like, how do we do this? So Phoenix, like if we're taking that last example, Phoenix emits that event that we saw, and then Mobius receives it because it's the reporter, and then it's going to pull out the metrics, and we save it to what we call the metric table, which is an ETS table. So we're using ETS tables under the hood to manage this. And then at some point, we have the scraper that goes along at an interval. By default, it's 1 second. It's going to trigger the interval. It's going to go to the metrics table, which is kind of like the metrics table is the most current state of your metrics. And it's going to take a snapshot of that. And it's going to pull that snapshot and then go save it to what we call the History.t data structure. The History.t, this is kind of where some of the magic happens. It contains 4 circular buffers. And so this is what gives us this helps us bound the memory because we give them default sizes that you can see on the slide. So it's not growing your circular buffer, your buffers, and the data you're collecting in memory isn't just exploding. There's definitely limits. And with a circular buffer, once that gets pushed down far enough, it just falls off. So you kind of lose that data. However, all this is configurable. So if you want less memory usage, you just pull down the amount of slots for each bucket there, or you can crank it up if you want more granularity. So the amount of space you have, you can configure the granularity through how the size of these 4 buckets here. And we use a waterfall strategy. So basically, when a snapshot comes in, we say, in the last 24 hours, have we received a metric for this 24-hour period? If the answer is yes, we push it down to the hour. Did we receive something in the last hour? And then if the answer is yes, you push that down. But if the answer is no for any of them, they just save them into their bucket. And that's how we're kind of storing. It guarantees that like you're going to have a metric for that day. And then we only write to disk on graceful shutdown. So for a Nerves device, if you do a firmware update, you're going to save all your metrics. And it's going to be great. If you're anything that triggers that graceful shutdown, if you type reboot in the console, but if you walk over to a Nerves device and you unplug it, well, you're going to lose some metric history and data there. So just keep that in mind as you explore Mobius. We want it to be useful without a central server. So we expose these 3 API endpoints that allows you, so Mobius.info will just dump the current state of the metrics that you have. Mobius.plot will give you a little bit of a time series plot. I think it defaults to the last minute and a half or 3 minutes, somewhere in there. But you can configure how big you want. It is a ASCII chart based time series plot, and so there's some limitations there, but it definitely will give you like a good feel for a small amount of time. And then Mobius 2 CSV. So if you do want to take it to a different platform, you can export the CSV, and then anything that can handle CSVs, you should be able to pull it in and do any type of analytics you want, or view it in any type of graphical way you want. So just some examples of Mobius, and I was just messing around. So I was grabbing off of our firmware, the signal strength and dBm over the last 2 days. So I got a CSV and I took it, this was from our studio, so I took it in the R and I graphed it. And this is the graph we got. So that's one way you can do some visualization. So I did it again. I looked at our boot count over the last 2 days. And I noticed that on the first graph, we're going to go back, there's that crazy spike there. Somewhere around the same time, there was an increase in our boot count. So when we went to 4 to 5, so I grabbed where that was and I plotted that vertical line. And I just found it interesting that this happened. So I kind of zoomed in a little bit more to when, if you look right where that blue line is, our dBm goes from negative 64 to negative 63. So I go and look a little bit closer. And I went to Nerves Hub and saw, oh, there was a firmware update triggered. And so that's what the orange line is, the first one. And the second line is when we booted. Now, I don't think this is completely accurate because, like I said, circular buffers, you're going to lose some granularity in data. So I think the blue line is shifted over a little bit. And in reality, it's closer to the firmware update triggered. And then when you see that jump to negative 63, that's when we reconnected and were able to get the dBm out of the modem. So I kept going with our CSVs and just trying to mess around with the API. And I looked at our transmit bytes over our LTE connection over the last few days, and I'm sorry, receive bytes. And my assumption was, oh, this will just keep climbing and climbing and climbing and climbing. But then when I popped in RStudio and graphed it, it just drops. I'm like, how did we lose received bytes? Which tells me the way I configured this metric is probably wrong, and I need to go fix how that works. But what is interesting, after October 6th at 1800, you see another dip. Well, the firmware update happened after about that time. So yes, my slides were a little out of order, but I did, so first off, before I noticed that, I was like, okay, what is our disconnect, right? Because we're tracking how often we're disconnecting our account for that. So I went and looked at it, and you can see that it jumped up twice, roughly in the same window as the crazy drops in receive bytes. So I grafted those two increments when those two values were incremented on the vertically, and then there seems to be a correlation between when that modem disconnects and has to like restart and its receive bytes going down. So that tells me how I misconfigured pulling in that that metric. And then I zoomed into the area where there was a firmware update. And this is where we see that first line is when the firmware update was triggered. The next line was when we got a boot count. And then the red line is when the disconnect registered. What's interesting here is you lose data with circular buffers. And I think this is a good example of understanding what's going on. And maybe we want to increase our amounts that we're saving for each bucket. Because my assumption is that red line actually should be shifted over to the left. That last line there should be shifted over. And we're just losing granularity, or the circular buffer is popping out. It's gone through its thing and it's dumping data away from us. So this is some of the APIs and just some examples of how you can still do like data visualization through different tools by exporting the CSV. So role maps and features. There's a lot here that I would really like, but it'd be cool to get alerts. So to solve the problem of a lot of times observability is really good at letting you know there's something bad going on. But if you're not connected to a server, how are you going to know that? Well, it'd be really nice to say at this metric, at some threshold, handle like alert somebody. So then the consumer can set up a way to push up alerts through the network connectivity, which will minimize constantly blasting a server and pushing bytes out. And just really the cost of that alert, maybe you're on LTE, the cost of that alert monetarily for those bytes might outweigh the cost of what's something bad that's about to happen. So in bundling, being able to bundle up all this information and send it up to a server maybe and have that option, because right now there is no option for a larger server to get like fleet-wide or based view of what's going on with the metrics for all the Nerves devices. So it'd be nice to be able to have some other server that can accept this bundle and allow for further data visualization, data analysis, or general just being able to see how your fleet, the health of your fleet is doing. And there's a couple other ones that'd be nice to iterate on the API a bit and kind of hammer out, make it a little bit nicer to type out on the console because it's kind of painful, as you saw. So those are some of the roadmaps and features. If you're interested in that, just reach out and make a pull request or an issue. These are my sources for the articles, and that's all that I have. So thank you for watching this.